Hey folks, how you doing today? Today we're doing the very last section in our course. It's Unit M, Multiple Linear Regression, Dummy Variables using Excel. Now I just want to remind you that in the lecture videos folder, we go into this in more detail, so you certainly want to take a look at that. But I'm showing you how to do this in Excel, and we will read the output coming from that. So let's take a look here then at an example that I've set up for you. You'll recall that I've been using the Stats 101 data, but there isn't really a good example of using dummy variables there. So I've created another one, and I've got some data down here. Let me just scroll down here to the wordings that I've got at the bottom here. So the first variable here is streaming, and it's the number of streaming hours of movies and TV shows per week. And that's going to be our Y variable. Our X variable will be age in years. And then we've got something here called a dummy variable. And a dummy variable is how we handle a nominal variable in regression. And so a nominal variable that has two classifications, in this case, male and female, and keep it in mind that we might have some others, but we probably don't have enough to be able to do meaningful inferential statistics, so we've excluded them. So we've got left males and females, and so what we do is we create one dummy variable where the males are going to take on values of 0 and the females take on values of 1. And so we always name the variable after what you called the ones. So in this case, the females are the ones, so we call the variable female. And then we've got another one which we're going to create here in a moment, and that is age times female. And all it will be is just taking row by row each age value times the female value, and that's going to give us something called the slope shifter. And so let's go and actually create that now. And so we'll have a variable here called age times female. And in each row, I'm going to take the age times the female, and then we'll copy that down. And what we'll see here then is that when female is equal to 1, so when we're dealing with females, then the age times female value just simply takes on the lady's age. And so we've got 22, 17, 32, 34, 18. When we come to males, it zeroes out. So age times 0, because we're dealing with males, it zeroes out. And so every time we've got a male, you'll see that there are zeros down there. So that's what we call a slope shifter. And I'm going to show you how we use that in regression. So let's do some regressions now. So the first one that I'm going to start with is just simply my Y variable streaming regressed on X, the age. So just a simple linear regression. Let's go to data, data analysis, regression. And it looks like I've already got some stuff in here from before. So here's my streaming variable right here. All the way down. I've got 40 observations. And then here I'm going to use just the age. So that's my X variable. Remember to click the labels button here. Make sure that the labels is clicked. Don't worry about the constant, the confidence intervals. We're not going to worry about residuals. There's another demo that talks about that. You can take a look at the labs folder on that, as well as the lecture notes. However, we do want a output range. I'm just going to change this output range here so that we're a little closer. So something over here, and I'll put it right about there and press OK. And that's what I get for an answer. Let me just change the zoom on this just a little bit. I'm going to go to another page in a moment here where we can take a look at the added a little bit better. Okay, so there's my output here, and that's just looking at then the age variable down here. Now, let's run 2 more regressions. We're going to add a column each time. So in this case, what I'm going to do is I'm going to regress the y variable on age and female. And then the third regression is I'll do all 3 of them, age and female, and age times female. So let's do the other 2 regressions here. So I'm just going to come down here, data, oops, let's try that again, data analysis, regression. The only thing I need to do here is change the B to a C, and then change my output range so I'm a little bit lower here underneath the other table. So I'll put it at about 22 here. And this is what I get. So this one here then has age and female. Now let's do one last one here. Yeah, so that's going to be all 3 of them. So regression, I'm going to change the C to a D. So B, C, D, all 3 of the X variables, and I'll just change the output range here to right about there. And this is what I end up with. Okay, so now let's take a look at how we analyze that. I'm going to actually go over to another page where I've done that, and I've cleaned up the data a little bit here. And let's take a look at that. What I'm going to do is I'm just going to hide these first few columns because we've seen them already. We know that we've got streaming and female and age times female. We know what their definitions are. So I'm just going to hide them. And that'll give me this here. Now that's still pretty small in terms of reading it. I'm going to make it a little bigger, and we'll kind of jump back and forth a little bit here. But let's take a look at what we've got. So this was the first regression that we had here, which was regressing streaming is regressed on age. So a couple of things I want to point out here. The R-squared value. The R-squared value is quite high. So it's 69% of the variation in streaming hours is explained by a person's age. Overall, the regression, the p-value for the F test is 0, and because this is a simple linear regression, that should also be the p-value here for the age variable. So what we have here then is that age is significant at explaining the streaming hours of a person. Now, let's take a look here at these guys, which are the coefficients of the model here. All right, so that's the line here. And what I've got down here is the how I would actually describe the relationship here. So at this point, we haven't broken this down into males and females. So this is all of them together. And what we've got here is streaming hat is equal to minus 1.923 plus 0.409 age. And of course, that's these coefficients in orange down here. Now, for a 17-year-old, which is the youngest in the data set, let's just go back here for a moment. And so if we take a look at our ages, I think she's near the top. There's my 17-year-old. She's a female. And so I've got a 17-year-old, which is a female. I think the youngest male is an 18-year-old, somewhere down here. Yeah, there's an 18-year-old female, male. Okay. But let's go back to where we were. And so the youngest person in the data set then is a 17-year-old. And so what I'm going to do is take that equation, minus 1.923 plus 0.409, and then for the age I'll put in 17, and I'll get 5.04 hours. Now that's important because if you take a look at the graph over here, You can see I put in a line here. Hope you can see that. But it has a negative intercept, which doesn't seem to make sense. That means negative streaming hours. But remember, regression is good within a certain range. So we would have an age of 17, wherever that is. So we might have, an age something like, oops, well, that's not a very good line at all. But somewhere around there. Let me actually get rid of that. That came out pretty badly. But we would end up with a positive streaming number, in this case 5.07 for the youngest person, which is 17. And so we've got a general upward slope here. And I haven't put in any scale or anything like that, but you can see we've got a negative intercept and then a positive slope here that goes up here. So that's what the relationship looks like there. Okay. Let's just see what we've got down here. So the interpretation there is that, therefore, an average 17-year-old spends over 5 hours. That's the intercept. Sorry, that's not the intercept. That's if you stick 17 into this equation. 5 hours per week streaming shows, and this increases by 0.409 hours. That's the slope, which is about 25 minutes out of 60, for every year increase in age. So that's how we describe the relationship there. Okay, let's go take a look here then at the next regression. And in this particular regression here, what we've done is we've added in female. And female is the dummy variable. And what I want you to note here is that the R squared jumps from 69% to 76.7% just by adding the female variable. The overall significance here, the F-test, is that both variables together, age and female, do significantly explain the streaming of a person. And if we go down here, we'll see that the p-values are really low, close to 0, and so that means that both of these are significant at explaining streaming. Now, here's how a dummy variable works. A dummy variable is an intercept shifter. And so we can come up with two scenarios here. We've got, for males, we've got streaming is equal to, and I'm just going to go down to the coefficients here again. This is the intercept, minus 3.79 plus 0.410 times age plus 3.377 times 0, because for males that drops out. And so that last term drops out, and we're just left with these two guys right here, the intercept and the slope. And so that's what we have up here. Streaming hat is equal to, for the males, minus 3.79 plus 0.411h. So now let's take a 17-year-old. And you might argue here, I've got a note down here. Notice that the youngest male is 18, but we're going to use 17 as a starting point so that we can compare the males and the females. And that's not much of a difference here, 17 or 18. So we want to use the same number as an input value here, and then see how the streaming changes as ages increase. So I'm still going to use 17, and what we've got here then is minus 3.790 plus 0.411 times 17 is equal to 3.17. So the interpretation here then is that the average 17-year-old male, remember this is for males, spends about 3 hours and 10 minutes, 3.17 hours, per week streaming shows. And then this increases by 0.410, which is about 25 minutes for every year increase in age. Okay, now let's jump down here to the females. The females is found by taking the intercept, minus 3.79, plus 0.410 times age, plus 3.377 3.77 times 1. Remember, the female variable takes on a value of 1 for females. These two are just constants. This guy and this guy are now just constants that can be added together. So if we add minus 3.790 and 3.377, you'll get minus 0.413. Now it looks pretty close to this positive 0.410, but that's just by coincidence here. So this is the line for females. So a different intercept, same slope. So now let's take a 17-year-old, stick that into the equation, and we'll have minus 0.413 plus 0.410 times 17 for the age is equal to 6.55. Therefore, the average 17-year-old female spends about 6 hours and 33 minutes per week streaming shows, and this increases by 0.410 hours, which is about 25 minutes per year increase in age. Now, this can be shown graphically this way. And so what I've got down here then is a female line and a male line, same slope, but the female line here has an intercept of negative 0.413 and the male minus 3.79. Again, those are both negative there, but when you get to a 17-year-old, you'll end up in the positive, positive for the y. So that's the relationship, and there is a significant difference between those two lines because this is significant. The p-value is significant for female. In fact, the vertical difference between the two is 3.377. So by sticking in a line for both a male and a female rather than trying to force them into one, our R squared increased from 69% up to 76.7%. But do they really have the same slope? So what we do now is we add in the slope shifter. So we're going to have here then a regression of streaming on age and female, the dummy variable, which is the intercept shifter, and then age times female, it looks like that kind of got cut off there, which is the slope shifter. And here's the results that we get. Look what happens to the R squared value just by allowing the two lines to have different slopes. It jumps up to 91.3%. Big increase. Of course, this is significant if you take a look at the F-test. And all of these guys here are significant. All three of these are significant in explaining the streaming of a person. One thing I want you to note in terms of coming up with the best model, and you'll see this in the lecture video here, is what you do is you just take a look at this guy here, which is the significance of the slope shifter. In the earlier versions, we found out that, of course, age was significant, right? So we know that's a significant variable. When we added in female is significant, so we know both of those are significant variables. It is possible when you put in the slope shifter that one or both of these could become insignificant. In fact, all three could become insignificant. If either of these becomes significant, we would still say that this is the best model as long as the slope shifter is significant. And that's because we've got big problems with multicollinearity. Of course, you're going to have a very high correlation between age times females, the slope shifter, and the dummy variable. Because, of course, anytime you got a zero on the other. And so you're going to have that. And with age times female and age, they should be highly correlated too, right? So that's a problem that can often occur as multicollinearity. But what we do is we say, hey, if they were significant in the above regressions, then even if they turn out to drop in significance, which would mean high p-values, as long as this guy is significant, the slope shifter, we would say that's the best model. Now, if that's insignificant, then we would get rid of this regression and we go back up to this one here, where they're both significant. So that's how you handle that. But let's take a look then at how we interpret this. So for males, what we've got here is 4.102 plus 0.0202. That's these guys right here, these coefficients. So we've got the intercept of 4.102 plus 0.202 times age. So that's for males. Minus 10.990 times 0. Right? The female variable takes on a value of 0 for males, so that just drops out. And so does the slope shifter. The slope shifter was 0 for males, 2. So these two would actually drop out, and we'd just be left with these top two here, which is what we have over here. So here's your regression equation. So let's take the youngest persons, a 17-year-old. Let's stick them into the equation. So we've got 4.102 plus 0.202 times 17 years old is equal to 7.54. Therefore, the average 17-year-old male spends about 7 hours and 32 minutes per week streaming shows. This increases by 0.202 hours, which is about 12 minutes, right? 12 out of 60, for every year increase in age. Now let's take a look at the females. Now with the females, what we do is we say we've got 4.102 plus 0.202 times age minus 10.990 times 1. So that's just a constant, which can be added to the intercept. And then plus 0.378 times age, because this particular variable becomes equivalent to age for females, and then it zeroes out for males. So what that means then is that the intercept is found by taking the original intercept and this guy, right, which is the coefficient for females, because that's minus 10.99 times 1. So you add those together, and you get about minus 6 something. And then the slope for age is found by taking these two and adding them together. So 0.0202 and 0.578 comes to 5.5 something. And in fact, here it is right here. So we've got, for females, we've got streaming is equal to minus 6.888 plus 0.580 times age. Let's stick in a 17-year-old, and what we would find is that she would come to 2.98 hours. So therefore, the average 17-year-old female spends about 3 hours per week streaming shows. This increases by 0.58 hours, which is about 35 minutes for every year increase in age. Let's take a look at the graph that I've got down here. And what we've got here is we've got a female line that has a negative intercept down here, and then a steeper slope. And then the males have a positive intercept and then a flatter slope. And at some point they cross. So they cross, and I'm just going to show you how we calculate that in a moment, but they cross at 29.05, so 29 years of age. And at that point, if you stick that into the equation, you'll get 9.96 hours of streaming. How do they get that? Well, what you can do is you can just simply take this line here, right? That's the one for males, and equate it to this line here. Streaming hat is equal to streaming hat. And then just collect terms and solve for age. What you'll end up with actually is just these two guys down here. And so if you took the negative of the female coefficient and then divided it by the coefficient for the slope shifter, you'll get where they cross, the age that they cross. All right? Now that's just algebra. Just take a look at those two equations and you'll find out that when you collect terms, that's the two numbers that you end up with. So that's the difference between the lines there. So we've got 29 years of age. So we've got down here, finally the two lines cross at 29.05 years of age. So that's sticking that into the equation here, either of the equations, because of course they're equal at that point, and we get 9.96 hours of streaming per week. Therefore, for people younger than 29, males spend more time streaming than females. So you can see that the male line is higher than the females before 29. And then after 29, females spend more time streaming. And so this is how we would describe the relationship, all this stuff here together here. Describes the line for the males, the line for the females, and where they cross. So that's how we do that. And again, this is a significant increase in the R squared, going right up to 91% by allowing two lines, one for males and one for females, and allowing them to have different slopes. And so that is what I want to show you in terms of how to run dummy variables in regression and how to interpret the results. And that's where I'm going to end the lesson today. Thanks for tuning in.